Hello everyone, and welcome to this tutorial on how to run Comsol simulations on Nimbix clusters. So since you're watching this tutorial, I'm going to assume that you already know what Comsol is and how to use it, at least the basics of it. So I'm rather going to focus on how to use Nimbix and then how to run Comsol simulations on Nimbix clusters. So Nimbix is a small company founded in 2010. They're based in Texas and they provide purpose-built cloud computing for AI, machine learning, Comsol answers, and many other applications, probably way more than we will ever be using. This is their website, but what I'm actually going to focus on is not their website, of course, but their platform for starting clusters. So if you want to go to their platform, just type in platform.jarwise.com like this, and then you can just log in. So hopefully you already received your username and password from your group, or otherwise you have to contact your group administrator who is responsible for Nimbix. So once you log in, then you're redirected to their really nicely done page where you can choose the different types of instances. So right now here I'm on the dashboard. This shows you all the active clusters which you're currently using and also paying for. So right now I just have one Ubuntu Linux cluster open, but otherwise it will list all the different types of clusters you can have. And also what is really nice, you can see like a mini version of that cluster, how it looks like. So right now I just have an empty desktop open, but later on when you have many instances, it will be useful because you can see what you're actually doing. So this is their interface. Just to give you an overview, when you click on compute, here you can see all the different types of instances which you can run on Nimbix. So when you have a closer look, you can see there are lots of ANSYS instances. I'm not going to focus on ANSYS in any way, but it should be quite simple if you know how to use ANSYS. You can just click on this, open an ANSYS instance, the kind of instance you want, and then start editing. When we continue scrolling a little bit, you can see different types of Comsol instances. So they more or less have all the versions, like the latest versions of Comsol available. I'll be using Comsol 5.4, which I also installed for you on our simulation computer of the group. This is the one where I made sure that it's actually compatible with Nimbix clusters, because sometimes it can happen that it's not precisely the same version and then he starts complaining. So just for information, when you continue scrolling a little bit, you can see really many different types of instances, most of which I don't even know what they do. So there's also MATLAB, and in case you're wondering if you can use the link between MATLAB and Comsol, at this moment, or like right now where I'm recording this video, it's not yet possible, but I asked them to add this to the developer list, and they'll get started working on this very soon. So hopefully by the time you're watching this video, there will already be some kind of Comsol for MATLAB possibility here provided by Nimbix. And if we continue scrolling, you can see many different types of machine learning applications. So for example, Power AI or Power AI notebooks. This is really interesting for machine learning in case you're into that. Then you have TensorFlow or TensorFlow GPU. So they have nice GPU clusters. I use them a lot actually in the past. And yeah, whatever you need, you can probably, or there's a good chance you can find it here. Okay, back to the main page. I said, yeah, you know what you can do with compute. You saw the dashboard. Then you can get also some basic account information. So right now I'm the administrator for this group, even though I'm just the only member. For you, this might look a little bit different, but yeah, you can see the team. You can see all the different people who are in the team, or at least I can see it. And this is where I could invite a new member. So if you don't have an account yet, contact the administrator and he can just invite you and create an account for you. The last thing which I wanted to show you on this website before we really get started is the following. When you click on dashboard, in the bottom left corner you can see the following small window. So here you can see how many core hours you used up. Here it's 2 hours, how many hours or minutes your clusters have been running, which is not the same obviously, given that you're using big clusters, and how much money you spent in that particular month. So I'm not sure if it's going to show you just how much you used. For me, since I'm the administrator, it's going to show how much the entire team has used, but I'm the only team member, so this is currently not any different. Okay, so let's get started. You type in Comsol. If you don't want to scroll for a while, you select Comsol 5.4. The batch mode isn't really interesting for us because, well, we don't have a license for Comsol on Nimbix in order to save money, but instead you're going to use Comsol Multiphysics, which is actually much more convenient. So the way you start the server is the following. I'll just zoom in a little bit so you can see this better. So you have many different types of instances. So these are 16-core machines with 128 gigabytes of RAM, but you can choose several different types. So I normally choose this one. It's the latest one, 20-core Intel Skylake with 192 gigabytes of RAM. Not that that's an issue. And then you can choose how many of those computers you want to be connected into one cluster. You know, you can really go up to crazy amounts, which you should not do if you haven't tried it before, unless you want to quit your job tomorrow. So let's just pick one with 20 cores, you know, really simple one for $3 an hour. Then you can also have a look at different options. You can add a job label if you want, a wall time limit. So if you're the kind of person who forgets to close servers and then goes on vacation and after a week realizes that you spent hundreds of dollars, then maybe you can enter some number here just to make sure this doesn't happen. Yeah, the screen resolution and yeah, the storage type, you normally use the premium storage, which is the one they provided us for free. And previous submission, well, this is currently not so important. So yeah, now you're ready to start to submit this job. Just click on submit. Then you have to wait for a few seconds for this to be processed. Currently, we're just seeing the one server which is open, which has already been open before, but now, as you can see, the Comsol server is starting. So they have really many computers actually just sitting around and waiting for you to use them. So it took just a few seconds for this to be started. If you want to run something on a really big cluster with, let's say, 1,000 cores, so that's 50 machines, then of course you might have to wait for a minute or two just for them to, you know, reserve all the computers for you, connect them into one big cluster, which is obviously not easy with 50 computers. But so far I never had any problems with this. So here you can see like the miniature version of how your cluster looks like. And normally you just click on this and then it gets opened in a new window. But since we don't have a license for Comsol, this is actually not gonna do anything for me right now. So by the time you use this, hopefully they will have fixed this issue and the server won't automatically close. So by the time you open this, you should reach this window. Looks like this. I cheated a little bit by opening a different type of instance that's not for Comsol. But for me, the problem right now is that Comsol automatically closes because there's no license, so the server is shut down. But Nimbix is going to change this soon, so you'll just directly end up having such a window. So this is a custom version of Linux, even though it says N here, it's actually Linux. And here you can see, you can just click on this. Maybe it will look slightly different for you, but the main point which I'm making here is that you click on terminal. This is just a classical Linux terminal. And then you can start Comsol Multiphysics server here. So we're going to work the following way. Instead of starting a Comsol graphical user interface, we're going to just start Comsol Multiphysics server. And then from our local machine, which I have open here, give me just 1 second. So this is our Windows machine, which we have as our simulation computer. I'm just remote controlling it. And there you open Comsol 5.4. So that's the latest one, which I installed for you. And here you can start any projects. And then instead of creating a file, transferring it to the server, then opening graphical user interface here, you can just remotely control the server. But in order to do this, you need to start Comsol MPHserver. So since this is not a real instance yet, I'll just type everything in a text document, which I have ready over here. So you can see this is like the terminal which you have over here. And you type in the following. Give me just 1 second to find this document on my computer. So you start with CD, which stands for change directory. So actually that's a way of opening a folder in any Unix command line. CD, you want to navigate yourself to the following folder. You type in user or USR, then local, Comsol, Multiphysics, bin, and another backslash, and then you hit enter. You're gonna end up here. So this time you're now in the right folder. It says bin, as you can see here. So you're in the right folder. Here you want to start Comsol MPHserver. So you type /Comsol MPHserver and hit enter. Then you'll be asked for a username. Here you can type in anything as long as you can remember. So I'm just going to type sbosh, hit enter, and then you'll be asked for a password. So you can just generate a password here. So one thing that might confuse you if you have never used Linux before, it's not going to start typing the password the usual way. Once you start typing, you're actually not going to see anything. It's just going to do nothing. But actually, he is typing, so that's all right. So you type in your password, hit enter. You type in your password again, and then you'll have to wait for a few seconds, and the following lines are going to be displayed. So Comsol MPHserver 5.4 started listening on port 2036. So this means that Comsol is now actually open over here. So, but it's not going to look any different. I mean, once you close this terminal, it's still going to look exactly like this. There's nothing you can see, but actually Comsol is open, but it's open in the background, and it's waiting for some remote commands to be sent to it, so it can process all the data which you want to be processed. So at this point, you're actually done with your graphical user interface here. So you can basically just close this window, but Comsol is still going to be open. So here it's already closed because I said I have the issue with the license, which is not yet fixed. But yeah, in reality, it's going to say Comsol here, and you'll still have the window open here. But you don't have to touch it anymore. Okay, so now we're ready to run the simulation. We're going to do the following. You go back to your Comsol instance. So I just opened a random file. It's just a demonstration file, nothing too smart. We're going to run a simulation using a different range of frequencies. Here you can see there's like a range. It's probably very small, so you cannot read it. But yeah, it's going to make like a for loop to different sample frequencies. Here, since I don't have a license, I'm going to do the following. So once I open Comsol on the simulation server at EPFL, it pulls out one of the licenses from the EPFL license pool for Comsol. They're like 50 licenses, I believe, and I took one of them. And I can actually share this license with Nimbix, and that way it's enough to use just one license. I'm not going to have any license issues after I manage to open this window here, which you can see. It works the following way. You go on File, then on Comsol MPHserver. So this is actually the server which we opened recently. You click on Connect to Server, and the following window opens. So remember what we did? We typed in the username, or I typed in the username sbosh in my case. The port, well, it's by default it's 2036, so it's the one which was already open. In the case that this port was changed for some reason, you can just change it manually here. But I'm going to leave it on default. So now username and password. So this is actually the username and password which you can see here on the Nimbix platform website. The address, that's the username. So you can just copy this and paste it here. And the password, well, the password is actually this one. It's auto-generated from Nimbix. And yeah, keep in mind, again, this is Comsol. It's supposed to say Comsol. For here, it's going to be Comsol. For me, it's just Ubuntu Linux, since some things haven't yet been adjusted by Nimbix. And then you just paste in the password here. And now you click on Connect. And so for me, it's not going to work, obviously. But for you, after a few seconds, it should be able to connect. Yeah, so it says no such host is known, obviously, because it's not a Comsol server. And after you manage to successfully connect, well, nothing is actually going to change. It's still going to look exactly the same like before, except that now when you run a simulation, it's not going to be run on your local GPU from the computer which you're using, but instead it's going to be forwarded to Nimbix, to the Comsol MPHserver, which is listening in port 2036, and everything will be calculated there. So basically, you're now they're indirectly controlling this huge cluster. I mean, it can be a huge cluster if you want it to be. Okay, now we're ready to actually test this in Comsol. So for this simulation, I'm just going to assume the following, that when you started Comsol MPHserver, that you selected 20-core Intel Skylake with 60 cores. So it's $9 per hour. That's 3 machines, 3 physical machines with 20 cores each. And yeah, then you submitted this job, opened the Comsol MPHserver, and connected your Comsol instance from EPFL to the remote server from Nimbix. This is just an assumption I'm going to use for this illustration. Okay, so now here we are. We're connected to the remote server of Nimbix, which with 60 cores in total, so 3 times 20 cores. And now we want to run the simulation. Okay, give me just a second. So one thing you want to do is you have to enable advanced options, because Comsol hides some options from like non-advanced users. At least that's what they do for making it look a bit easier. But you have to click on this little, so when you're here in Model Builder, you have to click on this little eye symbol, and then you enable advanced study options. You just click here. Nothing's going to change, but now when you click on study, actually you make a right click on study. Now you suddenly have way more options available to you than you used to before. So, but for the start, let's just pick a parametric sweep. So this you probably all know what it is, but this time we're going to use it differently. So instead of just running one parametric sweep, which is basically like a for loop going through all the different frequencies, we are going to enable different options. So click on add. Here we have sample frequency. This is the parameter which you want to for loop through. Then I'm just going to type in some specific range. So this range is going to contain 51 different frequencies. Details are not so important right now. And now if I would click on compute, then he would just take the first frequency, do all the calculation, and try to do the entire calculation of 51 cores, which would be completely inefficient, then take the second, third, and so on. But since we enabled advanced options, we have some different possibilities available to us. So you click on study extensions, then you click on distribute parametric sweep. So what he's going to do right now is he's going to allocate one job to one core. So we have 60 cores available, and the for loop is going through 51 different parameters. And what he's going to do is he's actually just going to allocate one job to one core. So 9 cores are going to be unused, but still it's going to be really fast. So I tried doing it without this being enabled. Then he effectively just, he didn't do much. It took 3 minutes, so it was the same speed as in our local simulation cluster, as if we were using our local CPU. But once you enable this, you get an almost 3 times speed up. The speed up isn't exactly 3 times because, well, the geometry has to be built, which is not so easy to parallelize, but apart from that, it becomes really fast. This is one option of running the simulation. So this was using the parametric sweep. But what we actually want to also test is not just the parametric sweep, so I'm going to delete it. We want to use something that's called cluster sweep. So since you enabled advanced options, now we can choose this option called cluster sweep. You click on it, and this option has some slightly more advanced options settings available to you. So you want to select the following. Well, first of all, we want to specify the same range. So we want to get a loop through sample frequency in the range, which you can see over here. And yes, again, it goes over 51 parameters. Now you have to select the following options. So the first thing you need to choose is number of nodes is 1, which may sound a bit weird, but actually, we have 3 nodes. We have 3 nodes with 20 cores each, but we select one number of nodes 1 because we want to, for one job, one frequency to be run only on one node. Also, you wanted to run number of simultaneous jobs. You want to make it equal to 1. Because then one frequency is going to be run on one node, on one core in that node. Otherwise, you would have a huge mess. And also, you want to enable the option synchronize solutions, because otherwise the output is probably going to be stored in 51 different files. I'm not sure about it, but you should always enable synchronized solutions. And then all you have to do is click on compute, and the results should be quite nice. The only drawback of this method is that it might take a while to build a geometry. But once the geometry is built, it should be super fast. So we are at the end of this tutorial now. Yeah, one thing I wanted to tell you is that if you check the description of this YouTube video, you will find at the beginning the instructions on how to open Comsol MPHserver on Nimbix. So what to type in the command line in the terminal. And also you will see some basic instructions on how to, what options to enable here and what different possibilities you have. So maybe once Nimbix changes his cluster and adds the MATLAB support for Comsol, I might do another video just to explain those details. And also it would be nice to actually be able to test it, because right now obviously I wasn't able to test this stuff because I don't have a trial license on Nimbix anymore. And yeah, I hope you liked it. Thank you very much.